Hi everyone and welcome back to Physics with Mr. Simons. This lesson we're looking at Newton's laws. I try to simplify the physics and get you exam ready, right? So looking at Mpumalanga 2014 where two bodies are pulled specifically with constant velocity at an angle, right? So again testing constant or simultaneous equations, right? When we say two bodies. Right, so let's look at the question. Question 2, they say a light inelastic string connects two blocks of mass 1.5 kgs and 2 kg respectively. Force is applied at an angle of 20 degrees on block A. So the force applied by block A, the force on block B is applied by a tension on the string, right? And they say if a force of 8.25 newtons is applied on block A, the blocks move at constant velocity on the rough surface. Calculate the horizontal component of the applied force. So we want the horizontal component of that 8.25 newtons. Right, and we want to calculate the magnitude of the normal force acting on A. Then calculate the coefficient of kinetic friction between the blocks and the rough surface. And 2.4, which is testing how will the frictional force change if we change the angle. Right. So as I said, you can pause here, attempt to answer as many questions as possible, right, and see where you get stuck and so on. Or you can work through with me through the problems and come back and attempt it on your own. Do it over and over till such time that you make no errors, right? But it's just a slight variation from the previous lesson we've done, right? And as I said, these small variations is what we use to catch you out in exam, right? 2.1, calculate the horizontal component of applied force. So once bodies are pulled in a straight line, horizontal component will always be my applied force cos theta. X is cos theta and Y is sin theta. So they said F is 8.25 newtons. My angle there is 20, cos 20. So my force in the X direction, 7.75 newtons. 1 mark for correct substitution, 1 mark for correct answer. Substitution in the correct formula, right? 2.2, calculate the magnitude of the normal force acting on block A for 3 marks. So my net force equal to 0, constant velocity. Net forces are balanced, so F net equal to 0. Forces acting on block A, so I have my force of gravity pulling down, normal force preventing it going through the surface, but at the same time I also have a Y component of my force, applied force. So normal force plus the Y force minus force of gravity equals 0. Don't get caught out with this. No? So whenever we pull a force at an angle, there's a Y component that acts with the normal force that ensures the normal force become a smaller force. Don't go write normal force equal force of gravity. So whenever we mark this wrong, that is the reason why. So normal force plus the force in the Y direction minus force of gravity. If I take Fg over, it becomes positive, and that is 2 kgs times 9.8, 1 mark for that. Force in the Y direction, if I take it over, becomes negative, and remember Y would be F sine theta. Ne? So there F is 8.25 sine 20 degrees. 19.6 minus the answer there would then give me 16.78 newtons. So 1 mark for force of gravity, 1 mark for force in the Y direction, and 1 mark for the answer. So hope we're following so far. Right, let's look at the next question. Right, now 2.3, they say calculate the coefficient of kinetic friction, meaning we want mu k, between the blocks and the rough surface. So look at the 1.5 kg and the 2 kg. So you can see this is a slightly different from what we've done in the previous videos. So we should know friction equal mu k times Fn for the 1.5 and the 2 kg. Right, now for the 2 kg, we worked out the normal force and we got 16.78. For the 1.5, all the forces are balanced there. So normal force equal force of gravity. So my normal force would then equal 1.5 times 9.8, which gives me 14.7. So here, my normal force is 14.7. So for friction, mu k times 14,7, right? But the key here is my friction is then equal to my tension because we're moving at constant velocity, right? So my tension there equals friction, so that tension also equals mu k 14,7. So T has mu k 14,7 and that T there also equals mu k 14,7. Right, for friction here, it's mu k Fn, my normal force was 16,7 N, so my friction here is F equal mu k 16,78, right, because normal force is 16,78. Now we know that my forces in the x direction must equal tension plus friction, right? Fax equal T plus F, right? So that is for my force in my x direction. For them to continue moving at constant velocity, they are balanced, right? So Fax equal T plus F, my tension being mu k 14.7, my friction being mu k 14, not 14.7, but 16,78 if we're working on the 2 kg, right? So we're working there on the 2 kg. So Fax we got in the previous problems. 2.1 is 7,75 newtons. Tension, mu k 14.7, friction, mu k 16,78, right? So there, take out the common factor, mu k, and I'm left with 14.7 plus 16,78. If we add that 2, that would give me 31.48. So 7,78 divided by 31,48 gives me then 0,25. So 1 mark there for getting my friction equation. Understanding the tension is the same as friction. Another mark there for correct substitution and taking out the common factor. So 2 marks there and 1 mark for getting mu k equals 0,25. Now 2.4, they want to know how will the frictional force on block A change. The angle between the force changes to 15 degrees. Remember the angle was 20 degrees. Now the angle is changed to 15 degrees. So technically, if I'm pulling something at the angle of 20 degrees, I'm making sure that less of that object is making contact to the surface. No? So the bigger that angle becomes, the smaller my frictional force becomes between the surface and the object. Right? But the smaller I make that angle, the more of the object is in contact with the surface, and then technically it should make sense that we have a greater frictional force. Right? So smaller angle, bigger frictional force. Bigger angle, smaller frictional force. So therefore, my frictional force will increase because my angle has decreased, right? So I hope you understand, right? I hope you follow what I've done. Continue practicing, work through it, get used to it. I wish you nothing but the best. God bless. Bye.